Okay, so we have talked about experiments and things that can go right and wrong about them. I want to talk about certain that elements. Let's try to back that up a minute. There we go. Elements that you can use to design an experiment. So these are elements of experimental design, right? One of them that helps us to keep on top of things is something called randomization. So we typically in an experiment create at least two groups, one that is a control and one that is experimental. So in the control group, they do not receive the treatment. In the experimental group, they do. We don't want people self-selecting into these sets, nor do we want to use some sort of marker to put them in these sets. So what we will do is we'll take our sample and we will randomize or randomly choose who to put in each of these groups. Something that's also commonly done is they do something that is like an ineffective version of the treatment. Okay, so like, let's say the treatment is that you have to take medicine. We might give them a pill that's exactly the same shape and size as the medicine that the experimental group is taking, but it might be something that's like made out of something that's inert. Instead of giving them like Lipitor, we're going to give them a sugar pill that's in exactly the same shape and size. And that'll give us an opportunity to even control that. This is controlling something that's called the placebo effect, which is something that's kind of documented that sometimes people will report responses to something just because they've had something done to them, so that they would think that they're in the experimental group. So if we do something to both groups, but only the effective part to the experimental group, we can keep down this placebo effect. So this is like a fake product effect. Okay, so replication is also something important. We want an experiment that can be repeated, and usually in order to verify the findings of an experiment, that's how you do it. You repeat the experiment and see if the same results happen. This is to ensure that this did not happen by chance. So we use replication to ensure the statistical significance of our findings. So if we can repeat it, it's not likely to have happened by some accident of sampling or something like that. Blinding. Okay, so we're not actually going to make anybody blind here. Blinding is the idea that the people who are in the control group and the experimental group don't know which group that they're in. And like something like giving the placebo pill would be something that helps with blinding. So you don't just go and say, hey, you guys are in the experimental trial, we're just looking at you. We want them not to know because then they can't skew the results. Okay. Sometimes we go to an extreme of what we call double blinding. So now you're blind to both eyes. No. Double blinding actually is, so the first blinding happens when you have the control and the experimental group don't know. But now you have the watchers. So you have the people who are doing the observations. So there's my little eyeball. They're watching the control and experimental group, right? I'll try a little nose there and another eyeball maybe. There we go. So these people, they don't know who's who. Don't know. N-O-W, there we go. Who is control or experimental. So if the people who are doing the watching don't know who is the control or the experiment, and they're just writing down the data that later on a researcher is going to look at, the researcher would know who's who, but the observer doesn't know. That also cuts down on the potential for bias. So the first blind is the subjects don't know. The second blind is that the observers don't know. Okay, so the last one is like other efforts to minimize confounding. Okay, so this is all about putting in controls. Put in controls. Alright, so for example, you want to make sure like your sample is a broad representative sample. So if you happen to take a sample and you manage to get a sample that is predominantly Caucasian, and you note that in your control group it is 100% Caucasian, and that your experimental group is, by some accident of sampling, is 25% other races, then you have an issue, okay? Because now you don't know if the results are specific to like people who are non-Caucasian, or if it's because of the treatment that you're giving, and now everything is confounded, okay? Because you're not sure whether or not these things have happened. So what you have to do is you have to look at your sample and say, have I put in necessary controls? And here, like, you want to make sure that your sample is representative of the population. And if it is, then how do we know? That will tell us that the treatment is something that would affect this entire population and not just a portion of it. So we want to look for any ways that we can avoid confounding by adding additional controls that would be useful. Okay, so to summarize, there are 5 elements of design that we're looking at here. There are others, but these are some of the big ones. We want to make sure that subjects are randomized, that we're not using some sort of method to put them into either the control or the experimental group other than a random process. We want to make sure that the experiment can be replicated so that it can be done by someone else somewhere else and achieve the same results. We want to have blinding. Blinding means that the control in the experimental groups have no idea which group they're in. And we would love to have double blinding. Which means that both the control and the experimental group don't know what group they're in, and the observer who's recording the data also has no idea what group these folks are in. And finally, we want to do things like implementing controls in order to minimize confounding. Okay, so 5 basic elements of design.